you what I'm about to say. Sunshine shit's here, you can take a break. I'm a hot air balloon that could go to space. With the air, like I don't care, baby, by the way. Because
So I'm here at the DevOps conference in Melbourne. There have been a whole bunch of great speakers at the conference in Melbourne covering technical and non-technical topics. Being a geek, I kind of like the technical topics and learning about DevOps practices and DevOps tools. There's a very vibrant DevOps community in Melbourne. There are lots of DevOps groups, and this is a great representation of the skill set and the people that want to be involved in IT and in DevOps in Melbourne, and it's a great place to be. Lots of people coming here and sharing their knowledge, sharing their passion for IT and for DevOps. It's a great, really great conference. I've really enjoyed it.
you don't waste your time. Here's why. Because I'm clap along if you feel like a room without a roof. Because I'm
Great introduction. Okay, so hi everyone. My name is Ariel Moscovich, and I'm here to tell you a story. That story is from a galaxy far, far away, at least 25 hours of flight. And it's mostly a production war story. It will discuss how we use Kafka as our main message bus at AppsFlyer, which problems we had along the way and how we solved them. Our first cluster looked like when we had really low traffic, and what were the requirements in order to go to the next level. Are we testing? Are we designing a new cluster? Are we testing them? Are we monitoring them? Are we backuping the messages? But most importantly, I will share with you our lesson learned that if you use Kafka, or if you will use it in the future, they will most likely help you. So I'm not sure if you noticed by my accent, but I'm originally not from Australia. I'm coming from a small country called Israel. We call ourselves the startup nation. I don't know why. I guess that's everybody that wants to be rich. But AppsFlyer is a startup that actually made it. When I joined AppsFlyer 3 years ago, we were a small company of 18 people, and now we're over 250. We had one small office. Now we have 12 offices around the world. And what we do is mobile analytics and attribution. We are enabling our customers to get better insights of where to put the money in the mobile advertising world. We support all the platform, of course, Android, iOS, Windows Phone, and so on. We have lots of integration, lots of customers. We mostly reside on a cloud. AWS is our primary cloud. We also have environments in Google. And if you have a mobile phone, and you most likely do, we are also residing in your pocket via our SDK that's integrated in our customers' applications. So show of hands, who from here works with Kafka in his environment? Everyone, excellent. So I can skip that part. So for those who are not familiar with Kafka, I will give a quick introduction, so you will know what I'm talking about. So Kafka is an open source, distributed, partitioned, replicated, publish, subscribe, commit, log, message bus. But what does it mean? Actually, it means that it's a queuing system that scale up, okay, scale out. And I will get a little bit into the terminology in order to give you a concept of how it works, so you will have the background. So the first item I will talk about is a topic. If, for example, you are using 2 or more partitions, you will all of those partitions will ensemble the topic for each one of the topics. Now, each partition is being held by one or more brokers. Brokers is a Kafka service, or if you have really high load, you can also consider it as a Kafka server, because there is no sense to put more than one service in one server. And we'll have 3 brokers. In those 3 brokers, one of those brokers will be considered as the leader, and the other as replica. You will have 3 copies of each one of your messages. Something that you should remember, producing and consuming to Kafka is done only via the leaders, okay? So they have extra load. So what you need to do is to make sure that your leadership of brokers in the cluster is evenly distributed. If not, you will have uneven loads on your broker, and this will cause to a cascading failure. We will talk about that in a few slides. One more item is retention. The different retention type in Kafka is time-based retention. For example, if you set a retention of topic of 1 hour, after 1 hour, the messages will be deleted even if you didn't consume them. Okay, so that's something that you need to remember. And the last thing is that all this structure of topic and broker partitions is being configured or being held in Zookeeper. So Kafka is using Zookeeper in order to have all this metadata and to know about its structure and so on. In older versions, it also the Zookeeper also held a offset of the partitions of the messages. Now is being done by the broker themselves. Okay, so let's proceed. So at AppsFlyer, we have endless stream of events that's coming from either users or from our SDK. Like I said, about 16 billion events per day. That's really a lot of traffic. So much traffic that one of our ELBs, we got notice from AWS that we have to split it into 2 ELBs because we got into the limits of 1 ELB in AWS, so it's really lots of traffic. And all these traffics are reaching our load balancer and from there to our web servers, and those web servers are producing those messages into Kafka. And for there we have some kind of a microservice architecture of services that consume from Kafka and doing some kind of operation. Now that operation can be, for example, to consume from Kafka and write to a database, or consume from Kafka and send post back to a customer, or consume from Kafka and do some kind of transformation for the message and write it to a new topic. So we have like an endless stream of events, like a river, that's Kafka is the heart of all these operations. You can understand that Kafka is really important for our production. So if Kafka is down, we're pretty much hopeless, and we need to make sure that it's happy. So there is also a RabbitMQ that you see here on the left, which I'm only mentioning because in few slides I will explain how we're going to remove that completely. It's using, we have small subset of messages that are also included in Kafka, but also in RabbitMQ. But we are going to eliminate that RabbitMQ and use Kafka only. So we'll talk about this in a few slides. So when I joined AppsFlyer 2 years ago, we really didn't have a lot of traffic. We had a few tens of millions of events. And we had a small cluster with a vanilla configuration, about 8 topics. Each one had about 8 partitions, a replication factor of 1 if one broker was failing. we lost data, which was really bad. It was consist of 4 brokers. We use instance type of M1 extra large, which is quite a older instance type in AWS, but it was chosen because it has 4 big local disks. Those are magnetic disks. They don't have really high IOPS, but it was enough for that period. And they give you 450 gigs per disk, double 4, it's give you a total of 1.8 terabytes per machine. And we understood that we need to migrate from that cluster because we saw that we have a boost in traffic and we had started to have capacity issues regarding to this capacity. And we also noticed that we have concurrency issue. We couldn't produce and consume fast enough from that cluster. And we also wanted to avoid loss of data in case of broker failure, which was really, we had one incident that we really tried to forget, and that was one of the triggers for us to go and work on a more robust, resilient cluster. So we ended up with much bigger cluster, 18 brokers of the same instance type. We divided them into, we use replication factor of 3, so each message was copied 3 times, and each one of the a partition was also be held by brokers that reside on different availability zones. It has pros, it has cons to do it that way. I will talk about that in a few slides, but what we could guarantee by that's by a single failure of broker or even a problem in an entire availability zone, we will still be operational regarding to Kafka, which was lagged before. And we also set a parameter that called broker imbalance ratio to a lower percentage than the default. What does it mean? It means that that percentage, let's say that percentage is set to 20%, it means that one broker can be up to 20% act as leader from the total number of partitions in the cluster. Okay, so the reason to lower it is to spread the leadership between broker as much as you can. So we lowered it, the default is 50%, we lowered it into 15%, which at the time was, gave us a nice spread regarding to brokers in the cluster. So in order to test the cluster, we use 2 native scripts of Kafka. Those scripts are able to produce loads regarding to producing and consuming traffic messages to Kafka. So that's gave us the ability to generate synthetic loads on Kafka. And we built out a dashboard in order to see how the cluster behaves when we loading it and when we are doing some bad things to the cluster and testing to see how it behaves. So and then we started to break things. We took one broker down, then we took an entire availability down of brokers, not in AWS, and then we tried to do something that's called reassign partitions on the fly. So when the cluster was alive and had lots of traffic, we shuffled all the brokers and partition in the cluster, so everything was like replicated again. It's like all the brokers had to change their data between them, which is all of those things, of course, are things that I'm not recommend to do on a production cluster. But we wanted to see that in order to make sure that the cluster can really be resilient to such failures. We use Airbnb plugin in order to collect metric from Kafka. It's enable us to collect metric like ISR. ISR is the ISR status. So if we have missing ISR, if we have not a complete partition regarding to brokers that are fully replicated inside the partition. We also getting from that plugin at the total number of metrics in the cluster and metric per topic, per broker, also leadership change. We wrote ourselves an internal application that calculates the lag of the consuming and also send that into Graphite in order for us to know what's the performance regarding to consuming from the cluster. We also use visualization tool that's called Kafka WebView that enable you to see the cluster structure and also let you to see the lag per partition in the cluster, which is very useful. On a Kafka cluster, we will talk about that in 1 or 2 slides. We also, I took this screen capture when we have one broker down, and you can see here in the ISR that there are broker or ISR that have missing brokers or missing replication. It's supposed to be 0, like it's here. So in that case, we had one broker failure because of hardware failure in AWS, and it took time till all the brokers can complete and replicate from the leader, and then it became a 0 again. Another interesting metric is leadership change. If there is a change in leadership in the cluster regarding to who is leading the ISR, you can see it there. It's usually 0, but it's like it's supposed to be. The second dashboard is from the client perspective. Here, for example, you can see the lag status. Here we can see that we had a lag and it was dropping down, which is good. How many messages were processed, how many messages was generated. Another important, very important metric issue in the cluster, so you need to make sure that that metrics is not indicating some producing issue to the cluster. So we went out with this cluster and we worked, and it worked fine for about 6 months. And then problem started to raise. Network saturation, all that's caused missing ISR because the brokers couldn't keep up. Either the leader were too loaded, so the replica couldn't pull the data from that, or the replica were loaded because they are pulling data. So it gives us like really an unstable state. And that's caused to 2 applicative problems. One was lagging consumers, and when I'm saying lag, it means that, for example, when we try to consume and send prospect to customer, it happens in delays and can take us at least, instead of immediately, it can take us lag of few hours, which is bad. Customers are expecting those prospects. Whenever there was a leadership change, the service that's produced was crashing, and we had to restart it manually. So it's really bad. There is a saying that I'm really identifying with when I have a production issue, especially at 4 a.m. It's says by the man this technology named after that the first sign of the beginning of understanding is the wish to die. Now it's a little bit morbid, but I want. That's another T-shirt that I want to make, and I'm trying to convince our marketing. They're not really cooperating. It's easier to stabilize Kafka than to convince them to do such T-shirts. But we'll get there eventually, even up to a month, to be able to configure our cluster properly with the new and with more traffic that we had at the time, and to get with all of the solutions that I'm going to talk about. So the first thing we did is to replace our instance type. Instead of the M1 extra large with the magnetic disk, we switch up to I22 extra large. At the time, it was the best that AWS AWS had to offer regarding to IOPS. Instead of the magnetic disk, it says SSD disks, and the I/O weight was dropped from 5 to 20% to 0 at once. That was a big win. The second thing is we noticed that one of our topics that handle our launchers, like application launchers, where everybody is in the mobile is launching the application, was about 80% of the total events in our Kafka. So, and those event types are the least critical ones. So remember, I mentioned that the client also gets the offset from the Zookeeper. And we used to use like a Zookeeper with EBS disks, and we noticed that the Zookeeper started to get I/O weight as well, and that's also affected our performance badly. So we didn't upgrade them to a very large instance, just M3 large or M3 extra large, but we used the ephemeral SSD disk with its 30 gigs of disk, which is more than enough, but it gave it enough IOPS in order to be able to support all these offset requests. We rewrite our producers in order to be resilient to leadership change. So now, whenever we had a leadership change in the cluster, we didn't have to restart our clients. That's a big bonus, right? Do more than what I presented before, that would be enough, but we wanted more. We wanted some more features besides just more higher concurrency and more attention. One thing that we wanted to enable that was really suitable for one of our applications is to enable log compaction mode. It's a different retention type in Kafka. Instead of time-based retentions, it enables you to keep at least the last message key for each value. So it really was suitable for an application for us. That's what it does. It saves commands of user integrations, and we don't really care about the history. We just care about the recent state of that command. So it's kind of make Kafka more like a database, in addition to his feature as a message bus, but it was really suitable for us, and we decided we want to use it. We also wanted to enable authentication and encryption, which was lacking in previous versions, for millisecond, which was really enough for us in order to get rid of the RabbitMQ and use Kafka alone, and that's really something that we wanted to do. So we ended up with upgrading Kafka into version 0.10.1. Currently running with 6 clusters. We running partition counts, depends on the loads, on the topic, but it's between 8 to 250, 240. We're still using i22 extra large. We tried to switch recently to i3 instances. Didn't really work for us. We'll talk about this in 2 slides, really interesting. We run over 100 topics, and we have about 1,500 K of producers and consumers. By the way, all of our services are running in container. Not that this means anything here, but just as a note.
Feel like that's what you want.